right, so we're going to start off by talking about the real number system. Everything that's going to be in this rectangle below is going to be a real number. And then we're going to talk about an example of where it's a non-real number. Within the real number system, there are rational numbers, which look like this. It's an R with two lines like that. And there are irrational numbers. And we call those IR. Okay, so we have rational and irrational. We're going to start from the smallest group outwards. Okay, so the first one are natural, and they're also called counting numbers. Honestly, the majority of the time, they're going to be natural. So let's talk about what a natural number is. So a natural number, or a counting number, starts at 1 and just keeps on going forever and ever. The way I remember that is it's natural to start counting on your hands, right? When someone says, all right, let's count it out in class, you would say, okay, I'm number 1, 2, 3, 4, 5, 6. Or if you start counting on your fingers, you start with 1, 2, 3, 4. So that's natural, okay? After natural numbers, we have whole numbers. So whole numbers, why not? Whole numbers, by the way, that's a W. Up here, the natural is just an N. Okay, so whole numbers are 0, 1, 2, 3, 4, and so forth. Okay, so the reason, or the way I remember the whole is that it's the exact same thing as the natural, except for we've just added in, so add in 0. Okay, I think of that as like a hole in one, and the pen to me looks like a cup, like the cup of the where the golf ball goes, it looks like an O, a 0. Or you could think of the O and whole. Okay, so you add 0 and then you go positive. You go up to infinity and beyond. All right, the next one is integers. Okay, so that would be here. Okay, so integers, we don't use I because we use that for irrational. So integers is actually a Z. Integers. So the definition of integers is whole numbers and their opposites. Okay, so if we think about, okay, whole numbers. So these are our whole numbers, right? Well, now we need to take the opposite. There's not an opposite of 0, 0, 0, right? But the opposite of 1 is -1. The opposite of 2 is -2. The opposite of 3 is -3, and so forth. So now, for integers, we have all of the negative and the positive whole numbers, okay? Within rational, there are a couple other things, okay? So for rational, we have fractions, and these are outside of the other circles, okay? So all fractions are rational numbers. And then we have two types of decimals. So we have terminating decimals, and we have repeating decimals with a pattern. And let me show you what both of those look like. So terminating decimals, here's a couple examples. Terminating decimals. So terminating decimals, if you think of the Terminator, he was there to stop, right? Terminate, boom, it's over. So terminating would be like 6.17, it's done. 6.17, that's an exact number. Or 18.40001. Okay, that's a terminating decimal. It is done. It is over. It has stopped. A repeating decimal with a pattern looks like this. So repeating with the pattern, it could be 4.17 and it could have the bar, right? Because if we read that, that's 4.17 repeating, or 4.17, 17, 17, 17, 17. Or you could even see it like this, 3.16, or let's not do 17 again because we just used that. 3.68888 ... Okay. The way I remember that these are rational is that you definitely always know what the next number is going to be. For instance, 4.17, if I asked you what's the next number, you'd say 1. Next number, 7, 1, 7, 1, 7. Over here, 3.68888, what's the next number? 8. What's the next number? 8. What's the next number? 8. Okay, so it's repeating and it has a definite pattern. It could be negative 6.798, 798, 798, right? We know that the next number after that is going to be 7, then it's going to be a 9, then it's going to be an 8. So those are repeating. And those are all of these numbers that I have given you so far are rational numbers, okay? These are all rational. Irrational, we do not have any subgroups within irrational, okay? So let's do pink. Okay, so there's a couple things for irrational. The biggest irrational number that you'll ever come around is pi. If I ask you, hey, which subgroups is pi in? Boom, irrational, and yep, it's a real number. We also have non-repeating decimals. For instance, 4.1768 ... 176. If I ask you what's that next decimal number, I don't know. Do you know? No, I don't either. It could be a 5, could be a 0, could be another 8. I don't know. So it's irrational. The way I remember that is I know down here we have the ... right here, right? These are the ... dots. But I looked for the pattern first. Once I found the pattern, I was like, okay, that's rational. Versus up here, when I see these decimals and I don't see a pattern, I think cray, cray, cray. Okay? Cray, 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 irrational. The only other thing that we could come across that is an irrational number are non-perfect squares. If you don't know your perfect squares, look them up. For instance, the square root of 49 is a perfect square, right? Because the square root of 49 is 7. Okay. A non-perfect square would be like the square root of 30, right? That's not a perfect square. Or the square root of 86. I don't know. Those are non-perfect squares, and if you put them in your calculator, I guarantee you they're going to give you a crazy decimal that repeats and has no pattern. That's why they are irrational. So everything up until this point has been a real number. The only time that you will ever see a non-real number, which believe me, it's going to be rare, so be for sure before you tell me it's a non-real number, is if you have a square root and the negative is inside. So the square root of negative, let's say 49. That is not a real number because let's take a real number, which is 49. Square root of 49 is 7. The reason that the square root of 49 is 7 is because 7 times 7 is 49, right? So the square root of 49 is 7, aka 7 squared is 49. It all goes back together. Over here, you cannot pick, like let's say I did 7 times 7. Well, 7 times 7 is a positive 49. That's not negative 49. If I did negative 7 times negative 7, well, negative 7 times negative 7 is positive 49. So I can't do that. I would have to have this, which those are not the same numbers. So you cannot have a negative inside the square root. Now be careful because a lot of people get this mixed up. Okay, according to order of operations, we do what's in the parentheses or grouping first. So the square root of 49 is 7. Drop down your negative, which is outside. So the only thing you're looking for non-real numbers is this negative inside the square root. Okay, so be careful. All right, let's do a couple examples. So I'm just going to ask you to do the check. The first thing you should see if you do this is just go ahead and draw your circle. Okay, so over here I've got natural numbers, whole, integer, or z, I guess, integer. These are all rational. These are all irrational. I've got pi, crazy decimals, non-perfect square. Over here, I've got fractions, terminating decimals, and repeating with a pattern. On every quiz, assessment, activity, that's the first thing you should draw, okay? Now we start in the inside. So -7, I'm going to say, okay, so -7 is a rational number. So I'm only looking at this side. It's a rational number, right? So now I go into the smallest group, which is natural. Is -7 a natural number? No. Is -7 a whole number? No. Is -7 an integer? Yes. So if it's an integer, now I go outwards. If it's an integer, it's also rational and it's also real. Okay, let's go to pi. Like I said earlier, you should just rejoice if you see pi because boom, it's on the irrational side. And if it's irrational, it can only be real because there's no other subgroups. The square root of 36. If you see a square root or a fraction or anything you have to simplify, you need to do that first. So the square root of 36 is 6. Now I have to decide, is it rational or irrational? It's rational. So now I start in the inside. Is 6 a natural number? Yes. Now I do everything outside. So if it's natural, it's whole. It's also in an integer. And it's also rational. And always don't forget, remember out here, they're all real numbers. All right, next one. -2/3. So -2/3, a fraction. All fractions, remember, are rational. So it doesn't have any of the small groups, but it is a rational number. And if it's rational, then it has to be real. Okay, 0. 0 is rational, so I'm going to the left side. Is it a natural number? No. Is it a whole number? Yes. So now I go outwards. Whole, integer, rational, real. And last one, 4.1439. All right, so I've got decimals. Now, the first thing I see is because I'm thinking that cray, cray, cray with the dot, dot, dot. But before I do that, I need to see if there's a pattern. So I look at the decimals, 1439. There is not a pattern. Therefore, it's a crazy decimal. Therefore, it is irrational and real. Okay? Please be careful with this real box. A lot of people don't go there. It is. The only time you do not have a real number is if the negative is inside the square root. Okay? All right.